Okay, so the notes that we have today, some of this stuff I need to do before answering a million questions. Some of this stuff will answer your questions after I do it, okay? I definitely want you to ask questions. I don't want you to feel like you can't. But if I haven't finished it, like if I do one thing and you ask questions about the very first thing I did, I'm never going to get done, okay? So try to, like, if I go over question A and then I'm ready to go on and then you have a question, let's wait till I'm basically ready to go on to B before you start asking, okay? And if I go too fast, I am recording a video right now, so you could always go back and rewatch that part or copy it down from a friend or copy it down from the video if I go too fast. Most important thing is we get the idea of what to do. And a lot of the stuff that you're going to have on your assignment, a lot of it's you just have to really understand how these things work and play around with things and persevere through. Some of this is not every single question on your homework is going to be exactly like the question we did in class. Some of it's going to be some perseverance on your part. So I'm not going to have an upload date because I want you to come back next time, and if you have questions, don't feel, I don't want you to feel like, well, I just have to turn something in, copy her work down. I want you to know that you can come in and ask questions if you don't understand something. And then of course I will post my work so you can see how I did it. Okay. On the assignment, all the stuff that I have in bold on the first page of the notes is what the assignment is asking you to do. So I'm going to go through and we're going to answer these things when we do examples, like down here. We'll answer these questions or do what they're asking you to do. But the first time I'm going to go through it and just talk about what it is. If there's anything we can add on notes-wise, I'll just throw it in here. So the first thing, when we have a polynomial, we're going to talk about the maximum number of zeros. Okay, and the maximum number of zeros I put in parentheses is the degree of the polynomial. So when I look at the first example down here, what is the degree of this polynomial? 4. Good. 4. 4 is the degree. It is the highest power in any of the terms. If it's in standard form, we should write it first, but it's not necessarily given to you in standard form. So the degree of this one, question A for this one is 4. That's the maximum number of zeros. So there could be less. So now I'm going to put some notes up here. There could be less. And it has to do with if there's multiplicity. So if I have an equation, f of x equals, let's say, x times x minus 2. Nah, we'll put 3 of them in there. X minus 3. There you go. In this equation, I have zeros at x equals 0, x equals 2, and x equals 3. The zeros are what I plug in for x that make the f of x be a 0. Now, if I use those as an ordered pair, now it's x-intercepts at 0, 2, and 3. Do we remember end behavior? So what's the degree of this example that I just made up on the spot? The degree is 3. Because if I multiplied it all back together, this is not in standard form. If I multiplied it all back together, I would have x to the 3rd as my biggest amount of x's. So the degree is 3. And when we have an odd degree, what does our end behavior do? Opposite. If it's positive as our leading coefficient, remember, it's going to go from down to up. If it's negative as our leading coefficient, it'll go from up to down, just like a line would. All odds are similar to lines, only weird stuff happens in the middle. All evens would go the same direction, either up, up, or down, down. So we need to know our end behavior, which should be prior knowledge. Actually, I think all of this is prior knowledge, according to my first bell. It's just how much did you remember? How much did you understand the first time? Okay. So if I were going to graph this, I would know that my end behavior says I'm going to start down here and I'm going to finish up here. And those are the only places that it would pass through the x-axis, because those are the zeros, those are the x-intercepts. At each place where these pass through, because each of these is to the first power, there's no multiplicity. And for x to the first power, that is like a linear at this x right here. It's passing through it like it's a line. It eventually curves, but right there, it's kind of like a line. And then at 2, it's passing through it like it's a line. And at 3, it's passing through it like it's a line, because the power is 1 on each of those. So if I were going to change the power on some of these, let's say I now have f of x equals x squared. I'll just make them, I don't know what I want to do. I'll make this 1 power, and then I'll make this one 3. I'm going all crazy here. So now I have some repeating zeros. I have what's called multiplicity. So what would be my degree for this one? What's my degree? I don't hear, so if you're showing me with fingers, I can't see. 6 is correct, whoever said 6. There's 2 x's, 1 more x, 3 more x's, 6 total would be our degree. So that means I should have at maximum 6 zeros. But looking here, I only have x equals 0, x equals 2, x equals 3. The 6 total come from some of them having multiplicity. So the x equals 0 has a multiplicity of 2. I didn't really leave myself a lot of space. Multiplicity of 2. And the x equals 3 has a multiplicity of 3. My end behavior this time is 6, so it's even. Leading coefficient is positive, so both of these ends are going to be up. When I get down to x squared, that first 0 at x equals 0, the first x-intercept, because there's a multiplicity of 2, the behavior at that x-intercept is going to be the behavior of a quadratic. So it looks like a little parabola right at that x-intercept. It's going to bounce and go back up. The multiplicity on x minus 2 is just 1. So that's just going to pass through like it's linear. And then the multiplicity on 3, I need to get rid of this dot. It's way too big. You won't be able to see what I do. At 3 says it's going to look like a cubic. So I'm going to have this like point of inflection right there. So the multiplicity at each x-intercept or at each 0 tells you what the graph does at the x-intercept. You guys know what a parabola looks like, right? So we just make a teeny little parabola there. If it's just 1, it passes through. So any evens with multiplicity are going to bounce, and any odds are going to pass through, just like end behavior. Okay? So we're going to use multiplicity to help us create graphs, because this is all non-calculator. The next thing that we're going to do is we're going to talk about how we can decide how many positive, how many negative, and how many non-real complex zeros this equation will give us. Okay, so what I'm doing with question B and C is I'm taking the infinite amount of zeros that we could possibly have, because there's infinite amount of numbers, and I'm going to narrow it down to just some numbers. Because right now, if I have a graph, I don't have an equation yet, but we have one for the next, here, just go back down. When I look at this equation right here, if I say graph that, find all the x-intercepts, you have an infinite amount of numbers that it could possibly be. So we could guess and check. We could start plugging in numbers and see which ones are x-intercepts, which ones are zeros. But that could take forever because they could all be fractions. So what we need to do is we need to limit the amount of work we do. So question, or I'm calling it question, I don't know what to call it. Step B and step C are going to help us narrow down what we have. So for B, what we have to do is we do something called Descartes' rule of signs. And the first thing that you're going to do for Descartes' rule of signs is we're going to find the max positive zeros. And on the graph, if you look just above it, the one that we were using a moment ago, just the first one, this has 2 positive zeros. This one has 2 positive zeros. How many negative zeros does it have? None. Has 0 negative zeros. None. Negative zeros. And then right here in the middle, it has 1 at 0, which is not positive and not negative, but it has 1 at 0. So to find the max positive zeros without having the graph, we're going to use Descartes' rule of signs. You're going to count the sign changes of the terms in the polynomial. So we're literally going to look at the polynomial and count how many times it goes from positive to negative or negative to positive. We're just going to count how many times it does that. And that's the maximum. That's the maximum positive zeros. There could be less, but that's the maximum positive zeros. We can also find the maximum max negative zeros. And to do that, we're going to first find f of negative x. So we have f of x. We're going to find f of negative x. And then we're going to count the sign changes. Now, that's the maximum number of positive and the maximum number of negative. To find like all the possibilities, the ones that are less than the max, we subtract by 2s. We subtract by 2. So if the max positives was 5, we could also maybe have 3. Or we could also have 1. We subtract by 2s. So I'll say subtract even amounts. And then one more thing that I'm just going to add it over here is for complex, non-real complex. Do you guys know what I'm talking about when I talk about non-real complex? Do we know what we're talking about? A plus BI. Here, let me just see. So non-real complex would be imaginary, but we don't want to say just imaginary because just imaginary is just the BI. So we're saying everything A plus BI. For those, they only come in pairs of 2. You cannot have odd numbers. No odd amounts. They come in pairs. And the reason why they come in pairs, the only way that I can get an imaginary number is to do what? How do we get an imaginary number? Square root of a negative number. So in order for me to square root something in this equation, I'm just going to go down to the one that we're about to do. In this equation, I see no square roots in here already. So in order to get a square root in one of those, that means I put it in myself. And if I put it in myself, it's actually plus minus. So those are always going to come in pairs because they're square roots. They're always going to come in pairs. Okay. Question C is going to limit possible rational zeros. Rational means fraction, or can be written as a fraction. So irrational would be square root of 5. Rational could be square root of 4, right? Because that's 2, which could be 4 over 2. So rational would be anything that could be written as a fraction. To do that, we're going to use our P over Q plus minus P over Q values. And the P values themselves are the factors of the constant term in the polynomial. They're the factors of the constant term in the polynomial. And then the Q would be the factors. Oops, sorry, my arm was on that thing. The factors of the leading coefficient in the polynomial. So factors would be like if I had 8, the factors would be 1, 2, 4, and 8. And we'll do that as an example soon. And then we find every possibility of P over Q. Okay, the upper and lower bounds are when we have a graph and we've got, some x-intercepts in there. I don't know where they are. Here we go. There are lots of x-intercepts in there. Okay. The upper and lower bounds would be the integers. Here, let me do upper bound here. This would be the highest or the, what do I want to say? I'm not sure how I want to say this. This would be the integer higher than any zeros. And then the lower bound would be the integer lower than any zeros. So basically, when we know what our upper bounds are and our lower bounds are, then we can say all of our zeros have to be between the lower bound and the upper bound. It's just a range at which all of our x's will be, all of our zeros will be, all of our x-intercepts will fall into that range, okay? And then to do it, it shows what to do, but this one, a lot of people have tons of questions on, and we're just gonna do it together. I'm just not going to try to explain it before we actually do it, okay? But that's basically what the upper bound and lower bound are, and they're x values. Ooh, x values. And then question E, we're going to find one or more of the following, depends on how much we can find without the calculator. We're going to find rational zeros, irrational zeros, non-real complex zeros, or if we can't find all of that, we might be able to find integers in which we know zeros are between, but we can't find them because they're irrational. And then to do that, we'll be using division, like synthetic or long. We will be doing possible rational roots, Descartes rule of signs, factoring, quadratic formula. We're going to utilize different things in different situations. We're going to write our factored form, question F, factored form if it's possible, if we get it factored all the way. And then we're going to sketch a graph. And it's not going to be super accurate. It's going to be kind of accurate, but not super accurate. And we're going to use things like end behavior, if there's multiplicity, where our zeros are, things like that to sketch the graph. Okay? So the first thing we're going to do is review synthetic division. And we're going to create a table of values. So synthetic division, if I'm going to pick, gosh, I forget what number I used in the first class. I think I used -5. I'm just going to pick a random value, okay? I'm picking a random value because I know the answers already. I'm going to tell you what we're about to do. You won't have to do by hand in your assignment, but I'm doing it by hand right now so you can have a appreciation that it's given to you, and so we can practice synthetic division, okay? So I am going to see what I get for this function when I plug in -5. So really what I'm doing right here is I'm finding f of -5, okay? But I want more information than just the answer. So that's why I'm doing synthetic division and not just plugging it in. So remember with synthetic division, we take the coefficients of the polynomial and we use all of the powers in descending order. So the fourth power, we have a coefficient of 1. Third, we have a -1. Then we've got a -16 for our second. We've got a 4 for our first power, and we have a 48 for our constant. Now, if one of those powers is missing, you have to hold its place with a 0. And one of those is on one of our examples. Okay, and then what we do is we add together this line, but there's nothing under there yet. So the first thing I'm going to do is add 1 with nothing and bring down 1. Then what we do is we multiply that by the number in the box. So I take 1 times -5 and I get -5. And then I add -6. Multiply, I get 30. Then I add 14. Multiply, I get -70. I add, I get -66. Multiply, I get, I don't remember, 330. Add, and I get 378. And I think this is what it looks like. Pretty sure this is what it looks like. Yeah, this is what it looks like on your assignment. There's like lines. Okay, do I need to go over synthetic division a second time? So what I'm going to do is I'm going to walk around the room and I'm going to have you all do the synthetic division on different numbers so that we don't all have to do 20 numbers or whatever it is. Okay, we're going to do all the numbers. I'm going to move this -5 first. Oops. I'm going to move it just so it looks like what it looks like in our worksheet. We're going to do -4, -3, -2, -1, 0. 1, 2, 3, 4, 5. We're doing all those, okay? So I'm going to hand out those numbers. I'm going to walk around, hand out those numbers, and then I want you to do synthetic division from the original equation, not off of the answer I got for 5, from the original equation with the number that I give you, okay? So how about you two do -4? How about you two do -3? I don't know, I'm just randomly getting it out. What's next? -2. You do -1, 0. How about you two do 1? You two do 2. Be helpful if you were paying attention. 3, 4, 5. Perfect. Okay, so those are the numbers that you guys are going to use for synthetic division, and I gave 2 people each number. So if I call on somebody and they're wrong, please the other person correct it so we don't have the wrong thing up there. silly mistakes happen. We are not using our calculator, but for time purposes, if you needed to multiply something really fast, I just turn my head. Sanjay, do you need paper? Did you already do it? Do you know what number you're doing? Okay. You got it? Can you tell me negative 4?
1, negative 5, 4, negative 12, and 96.
Okay. Does negative 3 have theirs? Well, whoever else is negative 3, is it you?
Yeah.
Okay, so whoever else is negative 3, if you get something different, then she'll just speak up. Okay, go ahead.
I have 1, negative 4, negative 4, 16, 0.
If somebody makes a silly mistake, it's not a big deal. I do it all the time. Who has negative 2? You want to read them off?
Got 1, negative 3, negative 10, 24, 0.
Okay, let me fix that so it looks like a 10 and not a 70. Who has negative 1? You guys, what do you get?
1, negative 2, negative 14, 18, 30.
Okay, who has 0? You guys back there? Oh, you have 0? Sorry, you guys have 1. Sorry, go ahead.
We have 1, negative 1, negative 16, 4, 48.
Okay, 1.
1, 0, negative 16, negative 12.
Negative 12? Or 12? I just can't hear. Negative 12? 36. Okay, who has 2? Oops.
1, 1, negative 14, negative 24, and 0.
Okay. Who has 3?
I got 1, 2, negative 10, negative 26,
And what?
30.
30. 4?
1, 3, negative 4, negative 12, 0.
And 5?
1, 4, 4, 24, and 168.
Okay. So when you guys go to do your assignment, this table will be given to you already. We created it. So if you need to create something, you can. It just takes a while because we got to do synthetic division a bunch of times. But this table will be already given to you. So now what we're going to do is we're going to use this table to find some information out about our graph. So what I have here is first of all, have a bunch of ordered pairs. Negative 5, 378 is an ordered pair on the graph. Negative 4, 96 is an ordered pair on the graph. So if I needed to graph this, I already have a bunch of ordered pairs. Negative 3, 0 is an ordered pair on the graph. What does that tell me right now? Louder. X equals negative 3. That tells me this is a 0. These are zeros. So you might already have some zeros when you get this table of values. Okay? All right, let's go back to the directions. So A was what's the degree, or not the degree, how many possible zeros maximum number of zeros is 4. Guess what we just found when we made our table? We already found zeros, but that's not question B, so we'll get there. Question B is possible, positive, negative, or complex. So we already know the answer to this, but you don't already know the answer for every single one. So we're going to go through this like we don't know the answer. So for part B, we are going to look at sign changes for our maximum positive. So from positive to negative, that's a sign change. From negative to negative, not a sign change. From negative to positive, that's a sign change. From positive to positive, not a sign change. So I have a total of 2 for my maximum positive zeros. For negative, we have to do f of negative x. So in this equation, I'm going to plug in negative x everywhere I see an x. And I'm also going to zoom in because it's really small. So I'm going to have negative x to the fourth minus negative x to the third minus 16 times negative x to the second plus 4 times negative x plus 48. And then I just need to find if the coefficients are positive or negative. Remember, if we take a negative to an even power, it becomes positive. A negative to an odd power becomes negative, and then there's already a negative here, so this is going to be positive. To the even power, x squared will be positive, so this is still negative 16. Then we get minus 4x, and we get plus 48. So now I do my sign changes. Here's none, and then we've got 1, and then we've got none, and then we've got 1. So our max negative is also 2 sign changes, or two possibilities. We're going to make a table. And this table is going to be positive, negative, non-real complex, and then the degree. The degree has to be 4. In my table, I'm going to start out my first line by saying we could have a maximum of 2 positive and 2 negative. If I have 2 positive and 2 negative, how many imaginaries could I have? None. Because these have to add up to equal our degree. Now I'm going to play around because I have the maximum number. There could be less. But they go down by even amounts. So if I have 0 positive and 2 negatives, how many imaginaries would I have? I would have 2 imaginaries, which would give me a total of 4. I could also have 2 positive, 0 negative, and 2 imaginaries, which would give me 4. Or maybe we don't have any real at all, and all of them are imaginary. So this would be all the different possibilities for positives, negatives, or imaginaries. This will be handy for you. It isn't on this one because I already know what all of the zeros are, but when you start doing your assignments, this is going to be handy. Okay. Remember, the imaginaries cannot have odds, only evens in that column. Okay, so that was B. I think C is the P over Q thing. So these are all the possible rational zeros. And I've got my p-value is 48. So I'm going to put all the factors of 48. There's 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And then the Q value is 1. So I'm going to put each of those above 1. Put 1 under each of those. I'm not going to rewrite it, okay? The next one will not just be so easy, but this would be all of our possible rational zeros. That means I will not have any zeros that are fractions. I could have zeros that are square roots of not perfect squares, irrationals. That will tell me nothing about irrationals. This only tells me about rationals. I think D is upper lower bound. Is it? Ooh, do. Yes, D is upper and lower bound. So we're going to look at our table for the upper and lower bound. So this is the upper and lower bound work. So you guys will already have the table provided. For the lower bound, and it says this in the directions for lower bound. For the lower bound, you're going to look straight across, starting at the 1, going all the way to see where the numbers are alternating signs. Do you guys see how at -5 we're alternating signs? Do you see at -4 alternating between plus and minus signs? Do you see that? Do you see at -3 we aren't? So that is telling me when it stops alternating the signs, this -4, the very last one that was alternating signs, is our lower bound. LB. I'll put it over here, but I just want to show you in the table. So above, or not above, but like more negative than -4, if I put in -6 or -7, they're all going to be alternating signs. But once you get to that -3, it stops. So we know that -4 is the lower boundary of our zeros. So lower bound is -4. For the upper bound, we look to find the first one that is all positives. Can you see what X value has all positives? Does everybody see that? I need to zoom in. 5. So between 4 and 5 is kind of that break. 5 is the upper bound. So all of the zeros are going to be between -4 to +5. So if I didn't already know the zeros are from my table, if I didn't know those already, then what I can do is I can go to all these possible rationals and I can just X out anything that is not between -4 and +5. So I'm limiting what my options are. I'm making myself have less work in the long run. Question E is to find all the zeros or whatever we can find, which we actually found from the table. So question E are going to be the zeros. And zeros are just numbers. And I do have on the board above Gracie's head over there, there's different examples of x-intercepts, zeros, roots, and solutions, which are all related. Like we find them all the same way, but like they're really different things. So we're finding the zeros. And if you look at how I wrote the zeros on that little poster, if you can see it, if it's not like too shiny, it says the zeros are 2 and -1. So we write zeros as just a single number. Right above it, x-intercepts are written as ordered pairs. So you can see there's a difference. If I ask for zeros or if I ask for x-intercepts, those are different the way you'd write them. So we're asking for zeros. We're going to have x equals. And then I put them in order from left to right, from least to greatest. So we'll have -3, -2, 2, and 4. So those are our zeros. And we know that's all of them because we have a maximum of 4 zeros and we've already found all of them. Next is the factored form. So to find the factored form, we take each zero and we say, well, this is like separately. And I know you guys can do this in your head, but when the zeros get more complicated, you should know what to do by the way I'm doing it this way. So in order to find the factor, we have to make this equation say equals 0. So I add the 3. So my factored form, f of x, is going to start with x plus 3. For x equals -2, add the 2. I get x plus 2 equals 0. So my next factor is x plus 2. I'm going to subtract 2 for the next one. So x minus 2. And then the last one, subtract 4. X minus 4. So this would be our factored form. And then the last thing is to sketch it. And you have a million ordered, not a million, you've got like 11 ordered pairs that you could use. We just want to make sure that the end behavior and the x-intercepts definitely are represented. And if there's any multiplicity, that it's represented in this picture. So 1, 2, 3, -3, -2, 2, and 4. We know the end behavior is even, so they're both pointing up. There's no multiplicity, so it goes through each of these once. No like bouncing, just like looks linear at each one of them. And if that's too much, like to just sketch it, you can use the ordered pairs and just plot them and connect it because you have ordered pairs in the table. Okay, what are we confused about? Sam. Well, we kind of talked about it earlier. I didn't write it down, but the original, this is even and positive.
Okay.
So anything even, is going to be facing the same way. And if it's positive, it'll face up. If it's negative, they'll face down. The ends will face down. Okay. What else? Yes.
For part C, where did you get the Q from?
So thank you for asking that because I didn't really label it in the picture. Let me put it in a different color. So our p-value is that last constant. The q value is the leading coefficient. And it was just 1. So that's where I got that one from. It's not always just 1. Good questions. What else?
So, did we have to use synthetic division in order to find, like, everything else?
You have to use synthetic division or long division to find zeros. In your assignment, I'm giving you the table, so you won't have to do as much synthetic division, but there's probably still some that you'll have to do on some of them. Okay? The only way to tell, I mean, that's not the only way, but the way that we're going to tell if something is a zero is we're going to use synthetic division, and if it ends in 0, then it is a 0. Okay? Because that makes the ordered pair something comma 0. So that's how we're going to tell. Let's start the next one because you see it a couple of times. It's going to be a little bit more familiar. But I've gone through the most, like a general one. But that one was kind of easy because we found all the zeros right away. That's not going to be as easy in your assignment. So we're going to start number 2. Remember how I gave you guys numbers for the synthetic division to make the table? Let's do the same number you did before. I want you to use synthetic division on this one. Just whatever number I gave you before. And that way I'm going to go around the room and collect those numbers so that it goes fast. -5, did you get it?
Or negative
We're
4.
doing -4.
You did -5.
Oh, dang it. Fine, I'll do one. -4, did you get it?
Yep.
What'd you get?
3, -9, 28, -114, and 460.
114, so we,
Yeah,
and then
sorry.
460. That's okay. I just went too fast. All right, -3.
3, -6, 10, -32, and 100.
-2.
3, -3, -2, 2, 0.
-1.
3, 0, -8, 6, -10.
0.
3, 3, -8, -2, 4.
1.
3, 6, -2, -4, 0.
2.
3, 9, 10, 18, 20,
What was the last number?
40.
3. Oh, Gus, you know what? I don't even have to go further. I can. Do you know why I just stopped?
Because they're all
Because they're all positive. And if they're all positive, that means everybody from there is going to have all positives. Am I right? Everybody else had all positives. So I'm just going to stop there. So that's something that I'm going to need when we write down the boundaries. So I just might as well stop. Did we find the lower bound? Where's the lower bound? At -3, yeah. And look there at -2, we have a 0. So all the zeros are between -3 and 2. So now let's actually start the ABC thing. A is how many max can we have? 4. It's our degree, 4. B is the max positive or max negative and then imaginary. So I'm going to do my max positive, which is the changing of the signs in the original question. So I go from positive to positive, that's 0. Then positive to negative, there's 1. Negative to negative, that's none. Negative to positive, there's 1. So 2 total. And then I'm going to do my max negative. I'll zoom in a second, but I can't. Well, I can kind of zoom in. I was going to say I can't see the equation and have enough space to write. So we're going to do f of -x to find the negatives. So I'm going to have a 3 here. I'll have a -3 here. I'll have a -8 here. I'll have a +2 here, and then a 4. So I've got 1 sign change. I've got nope, 1 sign change, and nope. So max is also 2. Max negative is also 2. We just did that exact same one. It's not very helpful because we just did this one. It's not different than the one that we just did. So there was 4. We had 2, 2, 0. We had 2, 0, 2. We had 0, 2, 2. And then we had 0, 0, 4. So those are all the possibilities for positive, negative, and imaginary. Question C is the P over Q. So for this one, my p-value is 4, and my q value is 3. So for all of my p factors, I will have ±1, ±2, ±4. All of my q's, I'll have ±1, ±3. So now I'm going to write every single combination of p over q. So I'll have ±1, ±1/3, ±2, ±2/3, and plus minus 4 plus minus 4/3. Those are all the rational possibilities. I think D was the upper lower bound. I think, was it? D? Okay. So, and we already looked at that. Our upper bound or our lower bound was, hold on. What was it? I don't remember. -3. Our lower bound was -3. And our upper bound was 2? Was it 2? 2. Okay. So just looking at that information with my upper bound, my lower bound, my P over Q values, and then I do know 2 of the zeros, I'm going to go ahead and just X some stuff out from my possible P over Qs. Like if my upper bound is 2, there's no way 4 is going to be a 0. Plus or minus 4, because my lower bound's -3. So I can just X those out for sure. +2 would not be one because we already typed that one in. -2 might be, but we actually made the table already, didn't we? Oh, so -2 is a 0. So we've just eliminated some of our work. So we know 2 zeros, but there could be a maximum of 4. Okay? Before I go and do anything else, I want to let you guys know that, remember with multiplicity, if there's a multiplicity at either at -2 or +1, if there's a multiplicity, I won't know by looking at this table here. If there's a multiplicity, because don't we need, let's see, let me go back and tell you why I'm talking about that. We have 1 negative and 1 positive 0 for sure. 1 negative and 1 positive 0. One of our zeros is at -2 and another one is at +1. In our table, there is not an option for 1 and 1. There's an option for 2 and 2, or there's an option of 0 and 2. So it can't be these. It has to be 2 and 2 because we already know 2 of our zeros and one's negative and one's positive. That means I'm missing 1 negative and 1 positive 0. They have to be between -3 and +2, so they're not an integer. Okay? They could be a fraction. They could be a multiplicity of the ones that I already have. Or they could be irrational. But they're not going to be imaginary because that can't happen with my situation here. So what you can do to find more zeros, I'm going to use this one as an example. Okay? Let's say we factored out -2. We use the answer for this one. I'm going to pull it down and I'll put it in a different color. Let me get rid of this. I don't need this right here. -2, we had left over 3, -3, -2, 2. And then we had a remainder, but our remainder we don't use. That was for -2. So if the original polynomial was a 4th degree, and I know -2 is one of the answers, and I pull that out, I'm now left with a 3rd degree here. But I don't need to put any like X's back in. What I want to do now is see if -2 happens twice. I'm going to see if -2 happens twice. So I cannot go back to the original because the original only tells me if it happens once. After I take out that -2, I'm going to use its answer and synthetic division a second -2. So no, it's not It does not have a multiplicity. So if this one doesn't have a multiplicity, the other one can't either. No, it could. I lied, it could. So we could check the other one as well. Just check that real fast. Whoops. This is a lot of just playing around with stuff, by the way. So the other one was 1. So we can, stop. The other one was 1. And I'm going to use what I got for 1. 3, 6, -2, -4. And I'm going to take out a second one. And there is no multiplicity. I just tried it. It didn't work. Okay, so no multiplicity. Oh, I spelled something wrong. There's no multiplicity. Okay, so that means the other positive and other negative are possibly fractions or possibly irrational. I want you to look at this table. These are ordered pairs. -2, 0 is an ordered pair. -1, -10 is an ordered pair. 0, 4 is an ordered pair. I want you to look over here for sign changes. From -10 to +4, it changes signs. That means somewhere it's going to hit 0. Do we have any numbers over here that are between -1 and 0? We got -1/3 and -2/3. So you could check those with synthetic division as well. You see, I'm just like using what I have here and just playing around with it to see if I can find answers. I'm actually going to show you one more way of doing it instead of just plugging in randoms. I know 2 zeros for sure. I know 2 zeros for sure. Sorry. I'm going to use the answer to the first 0. I'm going to use it again. So I'm trying something different now. We'll do purple. I'm going to use the answer to when I took out -2, and I got 3, -3, -2, 2. And this is when I took out -2. And from this, I'm going to take out the 1 that I already know. So originally, we took out 1 from the original. We took it out from the original. I'm going to take it out of the one that I already took -2 out of. Do you understand what I'm doing? Some people said yes, some people said no. This is going to be like a lot of practice and playing around with. So I'm going to take out the 1. I know it should work because it is a 0. It does work. So where -2 got taken out of the 4th degree, and then the +1 got taken out of a 3rd degree, then what degree do I have left sitting here? A 2nd degree, which is a quadratic. If you can factor out the zeros you know to a quadratic, you should already know how to solve every single quadratic. That's what Algebra 2 was really about, solving all quadratics. So if I can factor out every 0 that I can find, so it gets to a quadratic, I can now solve this equation and find the last 2 zeros that I need. Do you know where I got the equation from? So solve this, add 2, divide by 3, square root. When I square root, I'm at a plus minus. So I found out that I had irrational zeros. I had 2 irrational zeros. Okay, so step E is to write all of the zeros. So I had -2. I'm going to have negative square root 2/3, or you can write it rationalized. I don't really care which way we write it for now. And then radical 2/3, and then 1. And I knew that square root of 2/3 is less than 1 because the square root of 1 is 1. The square root of 2/3 has got to be less than 1. So I can put it in order just knowing that stuff. F is the factored form. So I'll have f of x. And each of these factors, I'm going to turn, or each of these zeros, I'm going to turn into a factor like x equals -2, and then move over the -2 so I get x plus 2. So the next one will be x plus square root 2/3, then x minus square root 2/3, and then x minus 1. Another way to factor it, this is factoring with linear factors. Another way to factor it would be you have your x plus 2, and then we use this equation as the middle two factors, 3x squared minus 2. And then we have x minus 1 at the end. That's another way of doing it. And then the last thing is to graph it. So we have -2. We've got +1. We've got something less than +1. We've got something less than -1. We have our end behavior is positive, opens up. They only pass through once. So it looks something like that. If you want to be more accurate, you have ordered pairs to graph. Like if you can't come up with that picture by just the information, you have ordered pairs to graph. Okay? Questions? Yeah.
Can you explain the purple part again, like how you got the numbers for synthetic division?
This one right here?
Yeah.
Okay. So the -2, I just went up to the 0 that I had, and I took these numbers here. Because what I had done was I had already taken out of -2 from the original function. So this would be a cubic after taking out the -2. So I just brought that down and rewrote it here. And the -1, that was taken out of the original. So that gives me a cubic. I don't want to just keep having cubics. I want to make them smaller. So I then divided out 1 from the answer that I had from the -2. Now, I could have started with the 1, brought that line down, and then taken out of the -2. It doesn't matter which order. I just went like the top one first. So when you guys were doing this last year, you would find something that works, then you'd take out the next thing that works and just keep making it smaller so that eventually we can solve what's left over. That's your goal. If you can't look at it and know what the zeros are, you're going to have to be able to solve it. And we know how to solve quadratics. If we get down to a 4th power, we might be in trouble because I don't know how to solve those. But we know how to solve quadratics. Yes.
For the multiplicity part, what is telling you then that?
Like this pink part here?
Yeah.
What's your question?
Well, what is telling you
That there is no multiplicity? Because after I took out -2 above, so I brought down the answer for -2, and then I tried to take out a second -2, but I had a remainder. If I take it out again and it ends up being 0, then it's a multiplicity. But if you have a remainder, it doesn't go in evenly.
So when it's a multiplicity, that means it, like if it's
It would like
negative,
maybe
it goes
bounce.
down.
Yeah. And when you're like have your factored form, if it's multiplicity, then you'd have like a squared, on one of those that bounced. Okay. That was like a lot.
So since it had a 0 on the end after you took the 1 out of the -2,
Right here.
that means that it was.
That means it is a factor, but we already knew that. I mean, it is a 0. We already knew that from above when we took it out of the original one. Like if it ends in a 0, it is a 0. Okay. But the reason why I took it out of the 2 answer is just so I could get a quadratic here rather than using the one up here that was a cubic. That would probably work. I mean, let me write what that equation is. 3x cubed plus 6x squared. I mean, this might even work. Probably didn't even have to do all that work. I got to get the rest of the numbers. Minus 2x minus 4. So if you only took out the 1, let's say you only took out the 1, and that's the answer to after what I took out the 1. Do you guys see where I got those numbers from after I took out the 1? That it looks like it factors. So you could find yourself that way too. If it factored. Doesn't always factor.
And since we already had
We already had this one. Yeah, we already had that one from before. So then that tells me this is what's left to solve. Okay. It's a lot of just using things that you've learned throughout the last couple years to find out what works, to find out your answers. Okay. It's going to be a lot of, this is not the way you do it for every single one. One you're going to factor. One of them you're going to have to use quadratic formula. One of them is going to have multiplicity. Like it's going to be different things. But
For the max positive and negative, do we only need that if we can't see the other zeros on the
yeah, if you don't have all the zeros in the synthetic division thing. Yes, but I'm going to ask you that you do it no matter what for the assignment. But if you see all of them, you really don't have to do the majority of what we've done. So I'm just taking you through all of the steps, but in reality, you don't necessarily have to use all of them unless I say you must answer this for a test. So I know that you know how to do it, okay? Okay, so let's do one more. And we're going to do the synthetic division help from the team again, okay? Everybody do their numbers so that we don't have to wait for me to do all of them. I'll do -5, I guess. Okay, before you do it wrong. Oh gosh, before you even do it at all, I need to talk about something on this one. I got to talk about this one. Before you do anything, do you notice every single term in this equation has an x? What can I do with that x? I can factor it out. So that's a 0. We've already found one of our zeros. Okay, so now when I do my synthetic division, I am going to do it off of taking the x out. So I have less to do. I've already taken out the x. I know that's a 0. I don't have to put that in this table. I don't have to. You can. You can. If you do, then you're going to have another 0 at the very end because you need that constant term. But I'm just going to make my table with without that in there because I know for sure that's a 0. I got some big numbers. How about you guys? So see, this is where it's already given to you, so you won't have to fill this table out on your assignment. But I made up equations and I didn't fill the table out, so we're doing it together. Did you get -4 yet? Okay. Oh shoot, I put it, wait a second, I did something wrong. I did something wrong. 1 goes down. Oh my gosh, I messed up because I tried to do it in my head. That was a bad idea. Well, somebody do -5 for me so I don't waste time. Just so I don't waste time. You have -4? Do I need to come back to you guys?
Yeah.
Okay, who's got -3? Go.
1, -3, -11, 53, -180,
And then what's the last thing?
380.
380?
Yeah.
Okay. All right. Well, I'm going to tell you right now, -5, -4, you have no reason to do it. Nope, I lied. We need to do it. I just lied. We do need to do it because I have 2 negatives in a row. They're not alternating. Just kidding. Ignore what I said. Somebody do -5 for me. Did you get -4? Still no? Who got -2? 1?
I got 1, -2, -16, 54. Yeah, we got different numbers. The 16
Okay, I'll come back to you. Who's got -1?
I got -4.
Okay, -4. Woo, this is a hard one. -4, go.
1, -4, -4, 36, -165, 680. You can go back to
Did anybody do -5 for me?
Yeah.
Who did it?
I did.
Okay, can you tell me it? It's 1, -5.
-5, 5, 5.
Another 5?
Yeah.
Okay.
-46, and then a big number.
Big number. Got it. Is it positive or negative?
It is positive.
Positive. Okay. Because that, I mean, that's really what matters is the signs. -1.
You can come back to me.
1, -1, -19, just positive 39, -60,
Big what?
80,
What?
80.
Oh, 80. Sorry, I just couldn't understand you. Is -2 correct, or I'm still coming back to it later?
You can come back to right now.
Oh, okay. -2.
52 instead of 54.
It's 52?
Yeah.
Okay. And then
-125, and then positive 270.
okay, who's got 0? Go.
1, 0, -20, 20, -21, 20,
And then what?
20.
20. Who's got 1?
1, 1, -19, 1, -20, 0.
Ooh, yay, 0. Like zeros. 2.
1, 2, -16, -12, -45, and -70.
70.
Yes.
3.
1, 3, -11, -13, -60, and
4.
1, 4, -4, 4, -5, 0.
Yay. 5.
1, 5, 5, 45, 204, and 1,040.
I think you said 1,040, but that one I can stop after 5, yeah? Do we have a lower bound? I was just writing down numbers, not paying attention. Do we have a lower bound? Do we have alternating? No? right, somebody do -6. Who's going to do -6? Not all of you jump at once. Everybody do -6. Go. Do -6. Is that our lower bound? Is that one's the lower bound, isn't it? Okay. So in my other class, we didn't even get that far in the notes. So I didn't actually know where the lower bound was for this one. So we have our upper bounds and our lower bounds at -605. So this one is a power of 6. So question A, there's a maximum of 6. Question B is the positive, negative, imaginary one. But let me tell you right now, we've already found one of our zeros for sure. Well, we found more on the table, but we already found one of our zeros right away. And that zero that we found is not positive or negative. So I am not going to do the sign changes with the original. I'm going to do the sign changes after I took out the 0. Because otherwise, it's not going to help us. We want to get rid of that 0 first. Gosh, my thing is not working. There we go. So I'm going to use, for part B, I'm going to do the sign changes on this one. And where I have like 0x to the 4th in there, that doesn't change signs. So it doesn't matter if you put the 0 in there or not. So we've got one sign change here, one here, 4 of them. So we've got 4. And then for the negative, I'm going to zoom in for this. So I've got a +1, I've got a +20, I've got a +20, I've got a +21, and a +20. That can't be right. Because the first one's not positive. I don't know why I said positive. First one's negative. So we have one sign change for negative. They should equal your degree, which is, well, the degree isn't 5, but after we take out the 1, 0, it'll equal 5 left. So when we make our table for this guy, again, I'm not including the 6 degrees. I'm including just the positive, negative, imaginary. So they have to add up to be 5. So 4, 1, 0 would be our max. From there, I can go down by 2s. So I could have 2, 1, 2. I could have 0, 1, 4. But I can't go down in my negative column at all. Because we go down by 2s, there isn't a number for that column. I cannot have odds in the imaginary column. So these are all the choices. So we know for sure one negative answer. Do we have that negative answer yet? No, we don't. So we know for sure one negative answer. Okay? Question C is the P over Qs. So what do we have here? So I'm going to use, again, I'm going to use the factored one after I took out the 0, because otherwise 0 would be my constant, and that won't give me any information. So after I take out the 0, I'm using my P as 20, and my Q as 1. So P over Q, this should be really easy because Q is just 1. Plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, plus minus 20. My lower bound is -6. My upper bound is 5. So over on my P over Q's, I can take out 10 and 20 for sure. And I can also take out +5 because it would have to be lower than that. I can't take out -5. However, I already have the table, so I know it's not -5. So I started with a 6th degree. I took out the x, so I'm down to a 5th degree. How many zeros do I know for sure? 2? Okay, so I'm going to start and I'm going to do synthetic division. Well, I already did synthetic division right here for taking out the 1. I already did synthetic division with the 1. So I'm going to use that. So I don't want to have to do extra work. So I have 1, 1, -19, 1, -20. I know that one of my zeros is 4. So I'm going to now use synthetic division to take the 4 out of the answer from the 1. So I can make it smaller. And it should be 0 because I already know that that is a 0. So at this point, we have 1, 5, 1, 5. We could see if it factors. We could check for multiplicity. Maybe there's multiplicity in this one. What do you want to do? See if it factors or check for multiplicity? I don't care. See if it factors? Okay, so if I'm seeing if it factors, then I'm going to, it was originally well, this was a 5th, and then I took out 1, so this is a 4th. I took out 1 more. This is the 3rd degree. So this will be x to the 3rd plus 5x squared plus x plus 5. If I do grouping, I can take out x squared times x plus 5. Did -5 work? Did -5 work? And somebody did it wrong? That was the one I was supposed to do. This says -5 should be an answer. Do you guys see what I'm saying? Okay. I wonder if -5 actually worked. What? Did you try it? 1, that'll be negative. I'm trying it. So that will be 25 plus 20 is 5. That will be -25. So that'll be -5. That'll be +25. So that'll be 4. And then that would be -20. So that would be 0. Oh, it is a 0. So somebody messed that one up. Wasn't me. Just kidding. I mean, I messed it up the first time. So then whoever did it the second time messed it up. Oh, good. -5 is a 0. Looks like we did some extra work we didn't have to do. That's okay. X squared plus 1 times x plus 5 equals 0. So now we know x equals -5. That's one of our zeros. And then we have x squared plus 1 equals 0. That is quadratic. I can solve it. When I square root plus minus, what do we find out? We find out that we have imaginary answers. Okay, so all of our factors. X equals -5. Was it 1 or -1? 1. 4. And then I'm going to put plus minus I at the end. factored form. I will have x plus 5, x minus 1, x minus 4. Now, at this point, if you do 2 factors or you do 1 factor, either will be fine. I'll do both. So I could have x plus I and x minus I, or I could have everything the same and then put in x squared plus 1 as my imaginary factors. Yes, Christopher? I totally forgot 0 as a factor. Thank you so much. And a 0. So 0 is one of these, so I need x in front. And then graphing it, we can only graph the stuff that's real. So we've got 0, we've got -5, got 1, 4. We know that our end behavior, well, we don't know. I didn't talk about it yet, but it's even. Is it positive? It's positive even. So we know that our end behavior is going to be that. And then these only pass through once because we didn't have any multiplicity on this one. Again, you can plot points and connect them as well. This was not 100% every single possibility. It was just kind of getting you used to the things you're finding. Now you're going to have to persevere and really problem solve to do it. I'm not going to have it have to be turned in by a certain date. I am going to post answers. You need to come with questions. Or come to me in XH with questions. Or send me email with questions. But you should not come having not tried something. Don't try number 1 and be like, I can't do it, and give up. Try something on all of them at least. Okay?